This video is a demonstration of how to replicate the graph that shows risky opportunity set indicated by this blue curve and the capital allocation line, which is this straight red curve, and the indifference curve, which is this blue curve here. And we want to have a nice graph that replicates the graph over here. And what we have here is actually a portfolio optimization model, and we pre-specify the risky assets available to us. This is a model of 2 risky assets. If you want to see the example for a model of many different risky assets, you can look at the example here. So there are 20 different risky assets here for example 2, and for example 1, there are 6 different risky assets here. And to consider to figure out the optimal risky portfolio, then we have to consider the covariance structure here for many different risky assets. If we simplify the questions into just having 2 risky assets, so we want to specify predetermined the expected return associated with asset 1, expected return associated with asset 2, the standard deviation, and their correlation here, the risk-free rate return. So how to come up with expected return of each individual risky assets? This will utilize the knowledge we learned before. So we'll do the scenario analysis, ideally, to assign probability to each of the future scenario and assign the return or the holding period return associated with different scenario. And we can calculate expected return and standard deviations based on scenario analysis. If that is impossible to implement in the practice, then we'll basically use average return from the past to give us an idea of what's the average level of return that that investor can earn in the past and the average level of standard deviation, since the volatility is quite persistent. Now, these are the input of the model. It can be changed to whatever numbers that you like. And we want to set up the model. So the idea is once we set up the model, down here, input all the formulas, we want it to be fixed, the formula to be fixed. Input can be different numbers. So once we change the input here, everything in the model will be automatically changed, all the calculation down here. So this is the top level philosophy of this model. And the rest is the implementation execution. So once we have these 2 assets, so the mean and the variance will define the assets, the risky asset, and we want to calculate the efficient portfolio by changing the weights here, since there are only 2. So the portfolio will be just varying the weights in one of the assets, asset 1, and the weight for asset 2 will be therefore 1 minus. So here 1 minus W will be the weight in asset 2. So calculating the standard deviation here, calculating the expected return here for the portfolio of 2 assets, asset 1 and asset 2 combined it. And we're actually using the weight here to construct one specific portfolio, and the standard deviation here and the return here will define that specific portfolio. Since the formula will be the same, so once you input the formula for calculating the standard deviation, which is the formula here, then you can just drag it all the way down since the calculations are the same. And for the return, the same return is the weighted average return. So we just set up the weight here, and according to the weight, we can calculate the return. So we have different, roughly we have here 25 portfolios, and we can plot these 25 portfolios on the graph that will show you a curve like this. And only the upper sides are efficient portfolios. So then the next thing is we want to introduce the risk-free asset here. This is the risk-free asset with a risk-free rate and 0 standard deviation, since it's risk-free. And then we want to draw a line, capital allocation line, that connects with one of the efficient portfolio on this opportunity set that can maximize the Sharpe ratio, which is the slope of this capital allocation line. There will be just one risky portfolio that on this opportunity sets that can maximize the capital allocation line. This will be the tangency point here. So if we want to further maximize the slope, then we cannot find any other feasible strategy. If there is other points that connect the risk-free assets on this curve, those are not the best, not the optimal risky portfolio, because you can further, there's a possibility you haven't reached the tangency point, there's a possibility that you can further maximize the Sharpe ratio, further make the slope steeper. Now, the calculation of optimal risky portfolio is solved mathematically. So we just need to know the weight, and the weight is specified here with this formula. And with this formula, we can figure out that the optimal weight to allocate in asset 1 is 52%. So that means 48% to asset 2. This will give us this tangency point here. And we want to know, so this is the weight, and we want to know the location of this portfolio. So that means we need to calculate the standard deviation, which is this part, and the mean, which is this part. So standard deviation 6.5%, mean is 1.2%. So for the purpose of drawing the graph, having one single dot is not enough to define this straight red line. So we also need Excel to know the risk-free rate here. So the risk-free rate here will be just 0.4%, and the standard deviation is 0%. So with these two data points, we can have Excel to draw a perfect straight line specified by this red line. Now, you know that the 0.4% is predetermined here, 0.4%, but the formula is way more complicated than just making the cell equals to 0.4% here. So this is because this nice setting here. So if you change the option and the input, we want to show the opportunity set, capital allocation line, and the indifference curve gradually. So the trick of doing this is to utilize the option or the number or the value here for D4. So when we choose opportunity sets, the value for D4 is 1. When we choose capital allocation line, the value for D4 is 2. And 3 if we want to put everything in the curve. And that helps us to form this if statement. So we will only have Excel to calculate the value for this data point, which will specify the risk-free rate if D4 is greater than 1. If the person that uses this model wants to see the capital allocation line or the or everything, including indifference curve. So if they want to see capital allocation line and indifference curve, then D4 will be greater than 1. If they don't want to see, then D4 will be equals to 1. So when D4 is greater than 1, so the value will be just 0.4. And here we still want to basically implement the weighted average calculation, but essentially since there's 0 weight for the risky portfolio here for E49. So this is the risky portfolio's return. This is risky portfolio's weight, which is 0. And we are investing 100% into the risk-free rate, which is B8. B8 is over here, 0.4%. So then you will have no doubt that this output will be 0.4% if D4 is greater than 1. This is chosen by the option here. And finally, so we'll have now at this point we have an opportunity set here, and we have a capital allocation line here, and we can specify the optimal risky portfolio. But since there is a risk-free asset, an investor has to make the decision for their capital, for their asset allocation decision. So they will determine how much proportion invest into risk-free, how much proportion invest into risky asset. So at this point, they will invest 100% in optimal risky portfolio. At this point, invest 100% in risk-free. In the middle, in the midpoint, they will invest 50% in risk-free, 50% in risky. Here, any point beyond optimal risky portfolio, they will over-invest into optimal risky portfolio and borrow money from the risk-free market at a risk-free rate. So the next step is, we want to help our clients and investors to determine which position they are in along this capital allocation line. So we want to understand their indifference curve. We want to understand their utility function. So this risk aversion level will be something you want to assess through some survey for the investors. You're not asking directly what their risk aversion level is. It's hard to answer concretely, but it will be something that can be estimated or inferred from their survey answer. And then for the indifference curve, with this constant utility value based on the utility function here. So we'll have the input of risk aversion. We also have the input of optimal risky portfolios expected return and the standard deviation. So the next thing is we want to draw the indifference curve such that all of the points on the indifference curve yields the same constant utility, So how to solve that? We will need to manually set up the standard deviation here from 0% all the way to 15%, and then solve for the return of the complete portfolio. And the optimal point will be the tangency point. This again is the mathematical solution. So it's someone solved it for us. We just need to apply the formula here. And the formula here is using the value for optimal risky portfolios return, subtracting risk-free rate divided by 2 times risk aversion times the standard deviation of optimal risky portfolio. So this 2.7 is therefore the standard deviation. It is, so all the standard deviation is nicely aligned or lines in this column for standard deviation here. And the expected return is shown in this, the last column here. This is because we don't want to mess up with the return here because we want to plot it. So to effectively plot it, so when you know, basically the data that used for plotting the green curve here is all of this column here. So if there's no data on the upper side, then Excel wouldn't plot anything here. Excel only will plot this part on the graph. So finally, what we have in the model is this minimum variance portfolio. So we know that there is a point that yields the minimum variance on the risky portfolio set. So we want to know the exact construction of that minimum variance portfolio, meaning that we want to solve for this weight. And the weight is here, which is given by this formula. It's also a mathematical solution. So which, you know, the objective function is just minimize the variance instead of optimizing the Sharpe ratio. So then the minimum variance portfolio is defined by 5%, which is the standard deviation, and 0.8%, which is the expected return. So we can show that in the graph here. Now, we have complete the model, and the rest is to replicate the graph. To do the graph, I want to do it in an intuitive way. So we want to first going from plotting the risky opportunity set and then add each of them one by one. So the opportunity set is defined by the all of this efficient portfolio here. So we have 25 efficient portfolio. We want to plot them, insert the charts to be selected. I think it will be the scatter plot with smooth lines and markers. Right, we can just put it here, make it larger. And next is to add the capital allocation line. So to add more line, you go to chart design, select data. So I want to name the first one first. The name of this will be risky opportunity set. And I'll add the second one, which is the capital allocation line. The X value should be standard deviation. So one is the standard deviation of optimal risky portfolio. Another one is the standard deviation of the risk-free asset, which is 0. The third point is not necessarily to be added here. So this is the extended capital allocation line where you invest 1000% in optimal risky portfolio. So having the first two will be enough. Having the third one will be also okay. Doesn't necessarily to include the third one for Excel to output the straight line here for representing capital allocation line. And here for the Y value, you want to select the expected return under the calculation of capital allocation line and click OK. Right, so then we can move on to adding the indifference curve. Select data, add. So the X value will be the standard deviation on this indifference curve, varying from 0% to 15%. And the calculation will back out the return based on the utility function with a constant utility value here. And click OK. And then we already have this 3 nice curve. So it seems that we don't need the full range to show the full range of x-axis. So I'm going to change the x-axis band. So you can double click the x-axis value here, and the Excel will probably automatically pop up the options or the settings for the graph. So you want to choose exit options and change the maximum level of the x-axis to 0.15. And for the y-axis, I think the level is from the maximum is 2.02. And the unit here, I want to change it because I don't want such a dense representation of the reference line. So I want to change it to 0.05. Okay, so the graph here is still not that informative. It needs to have a new chart title. Okay, instead of typing it, let me just copy it. So there are 3 special portfolios that we want to highlight it in our curve. One is the tangency point of capital allocation line and the opportunity set. So this will show you the optimal risky portfolio. Second one is the minimum variance portfolio available here. And the third one is the optimal complete portfolio here. That is the tangency point of indifference curve and the capital allocation line. So we want to show these 3 portfolios here. And also, if possible, showing the risky assets on the graph is also will be also helpful. So how to do that? We'll just need to add some more data into our graph. So first, name here, let me select optimal risky portfolio. And the standard deviation is 6.5. Return is 1.2. Okay, so that would be the first one. Second one, minimum variance. X is 5% standard deviation and 0.8% return. So add one more. This will be optimal complete portfolio that combines risk-free asset with risky. X value is 2.7%, standard deviation 0.7% return. And I also want to add asset 1, risky asset 1, X value 1.5%, expected return, X should be standard deviation 10%. And Y here should be 1.5%. And here, the last one is the risky asset 2. X value 5% standard deviation, Y value 0.8% return, and click OK. Right, we have a couple of points here. So the first one, this is risky asset 2. And this one is the complete portfolio. We want to add data label such that it will be more easy to view it on the graph. So I add data label, but I don't like it here because it shows the value only. I want to show the name. And finally, this should be the optimal risky portfolio here. And this is asset 2. We also need asset 1. X value is 10%. Okay. Since we have only 2 risky assets here, so if we invest 100% in risky asset 1, then it will be this curve. If we invest 100% in risky asset 2, then it will be this point. And anything between will be some proportion in asset 1, some proportion in asset 2. Inside of this 2 points, the curve that connects these 2 points inside this area, there's no short selling. But beyond this point, there will be short selling, and beyond this point, will be involving some short selling activity. So that will basically complete the application of the curve, and also I explained what the model did here, and hopefully that's helpful for you to understand the portfolio optimization modeling